So this video is all about exponential transformations. This is actually not something new. You've already had a whole unit on this. So you've seen A and K, C and D here. They all do the same thing that they did before, just with exponents. Maybe one new thing here is that B is the base of your exponent. Just one thing to watch out for. This was true in exponential transformations or in transformations in general, but it's also true in exponential transformations. The K value has to be factored out in order for you to read the right value for D, the horizontal slide. So if you get something like this, say f of x is 2 to the 3x minus 6, you might be inclined to say, oh, K is 3 here, that's the number multiplied by my x. And D is 6, that's the number I'm subtracting there. But that would be wrong, so don't do that. That's not true, because it's actually not in this form yet. You haven't put it into the general form equation. In order to get it there, you have to factor K out. So you need to rewrite this as 2 to the 3x minus 2, right? When I factor the 3 out of this, I would get x minus 2. Then I can write down K. K is the 3. And D is the 2. So my horizontal slide is a slide by 2, not 6. So just something to watch out for. All right, so going through each of these letters. First, A. A is an amplitude, and it does the same thing that it did with regular transformations of any old function. It's going to do, when it's greater than 1, it'll do a vertical stretch. So here's an example of that. In this case, A is equal to 2. That's the number out in front here is a 2. So it's going to take all the y values and multiply them by 2. So this y value here was originally at 2. Multiply it by 2, it'll be 4. This y value is originally 1. Multiply by 2, it'll be 2. This y value is originally half. Multiply by 2, you'll get 1. You can connect your dots to make a nice exponential curve there. When A is in between 0 and 1, it does a vertical compression. So that'd be this case here where A is a half. Works the same way though. You take all the y values and just multiply by A. So if this y value is 4, multiply by a half, I get 2. This y value is 2, multiply by a half, I get 1. This y value is 1, I multiply by half, I get a half. This y value is a half, multiply by half, I get a quarter. Okay, connect your dots. Make your nice exponential curve there. When A is a negative value, that means you're going to be doing a reflection, and it'll be a vertical reflection. Which is a reflection in the x-axis. So that means this y value of 4 will reflect down to be a negative 4. Y value of 2 will become negative 2. 1 will become negative 1. Half will become negative half. And what you notice with a vertical reflection is it looks kind of like a painting maybe of a mountain, and then your reflection is sort of like the reflection of that mountain in water below. So you should see this nice reflection in the x-axis. K is a little bit trickier. So K is going to be a horizontal move. Anything that's kind of snuggled up in against the X will be horizontal. So that's why D is horizontal slides. K is going to be horizontal stretches and compressions, but it's the opposite of A, if you remember from our transformations unit. So in this case here, K is 2. K is a number greater than 1. When you get that, that actually makes a horizontal compression, not a stretch. And it's going to be a compression by the reciprocal of K. So it'll be a compression by 1 over 2, or a half. So what I do is I take all the x values and I compress them by a half. So this x value was originally 2. I multiply by a half, it becomes 1. This x value was 1. Multiply by a half, it becomes a half. Anything on the y-axis stays where it is because it's at 0 originally, right? So 0 times a half is still 0. And then this negative 1 multiplied by half, it's going to compress inward. So it's like someone's kind of squishing it towards the y-axis from both sides to make a horizontal compression. And your exponential will kind of look like this here. So So when k is between 0 and 1, that's when you're going to get the horizontal stretch. So in this case, k is a half. So we're going to get a horizontal stretch by the reciprocal of a half. Reciprocal of a half is 2. So we're going to be stretching this by 2. So this x value was originally at 2. It's going to stretch all the way over to 4. This x value is at 1. We'll multiply 1 by 2, we get 2. This x value is 0, right? So it stays at 0. This x value is negative 1, so it stretches over here to negative 2. And then we can connect our dots to make our exponential curve. So you can see here someone sort of stretched it in both directions away from the y-axis. And lastly, when you get a negative k value, that's going to be a reflection. So all of our negatives are reflections. But this will be a reflection in the y-axis, or a horizontal reflection. So that means this x value, which was originally 2, will jump over to be negative 2, reflect there in the y-axis. This x value was 1, it'll reflect over here, become negative 1. This one's a 0, so it stays where it is. This x value at negative 1 will reflect over, be a positive 1, and my exponential will just sort of look like that. All right, last but not least, C and D, these are our horizontal and vertical slides. So C is a vertical slide. Or vertical translation. If you see it, C is exactly what you expect. So if it's like a -3 here, you're subtracting 3, C is -3, just means you slide every point down by 3. So this point here was originally at 4. It's going to slide down 3. 4 minus 3 is 1, so it slides down here to 1. This point was originally at 2. It's going to slide down 3. 2 minus 3 is -1. This point was originally at 1. It slides down 3 all the way down to -2. This point is originally at a half. It's to slide down 3 down to negative 2.5. You can see there's kind of like an asymptote, right, along the x-axis here. That asymptote line will slide down too, right? So that asymptote line will slide down -3. It'll slide down to here. So that means my exponential will never go below -3 there. Let's connect our dots to make our nice exponential curve. And it looks kind of like that. The D value here is the number that's either added or subtracted from x up here in the exponent. And it does horizontal slides. So remember that anything close to x is going to be a horizontal move. Anything that deals with sort of the function as a whole, so this -3 like at the end, will be a vertical move. So this +1 here is right up against the x, so that means it's going to be a horizontal slide. And horizontal slides kind of work the opposite of vertical slides. If you see a +1 here, that actually means you're going to be sliding backwards by 1. So this point was originally at 2, it'll slide back to 1. This point was at 1, it'll slide back to 0. This point was at 0, it'll slide over to -1. This point was at -1, it'll slide to -2. And your exponential curve will have the same shape as before, but be slid backwards. And that is it for our transformations.